Welcome back to our distance learning course, everyone. This is part 6 about selecting a sample in chapter 12. So we shall continue to types of sampling. You can refer to pages 234 to 239 if you want to read the text in its totality. So there are 3 types of sampling in quantitative research. The first type is random or probability sampling designs. The second type is non-random or non-probability sampling designs. And the last one is a mixed sampling design. So we are going to specifically cover random or probability sampling designs. This kind of designs is critical, is very essential in any quantitative study. So what do we mean by probability sampling designs or random sampling designs? I want to highlight the characteristics of random design. So in order to be classified as a random design, a random sampling design, or a probability sampling design, such design have to have this characteristic. Each element, each sampling element, or each sampling unit, or each participant or respondent of the population must have an equal and independent chance of being selected into your sample. So the key concepts or the underlying fundamentals behind random sampling design is that everyone in the population, in the sampling population, will have an equal and independent chance of being selected into the sample. Let me continue to explain the concept of equal chance, because this is very important. Imagine there are 80 students in your big class. Unfortunately, 20 of them refused to participate, or you could not identify them. You could not reach out to them for some reason. So the 20 students who refuse to participate or cannot be identified might have strong opinions about the issues you want to investigate. So when they refuse to participate, it simply means that not everyone have an equal chance of selection. In other words, 80 students do not have an equal chance of selection. Therefore, your sample, your final sample, for example, you might want to interview 10 people. The 10 people do not represent the 80 people or the total class. So equal chance is affected by 2 possibilities. Number 1, the participant refusals to take part in your research, or it's hard to find them, or they have already moved somewhere else. Regarding the concepts of independent chance, for example, one student in your class is selected. He becomes one of the 10 students randomly selected, but he refuses to participate. And fortunately, he said, yes, I'm willing to participate in your research if you allow, 4 closest friends of mine in the class to participate also. So he sets the condition. His participation is dependent on the participation by his 4 closest friends. So in this situation, we violate, the basic concept of probability sampling or random sampling, that every element chance of being selected have to be independent of each other. We violate that rule, we violate that concept. This independent chance concept also apply if in a community, some members say that they are going to join your study, participate in your study, if us that are close to them, for example, are allowed to do so as well. Fortunately, if a fairly small number of refusals occur, that's okay. If a small number of people who refuse to participate in your study, it should be okay. But if so many people refuse to participate after being randomly selected, it's gonna affect the result. It's gonna affect your research results. That's it regarding the concepts of independent chance and equal chance of being selected. Let's move on to 3 methods of drawing a random sample. In the previous moment, we talked about key attributes, so key characteristics of a probability or random sampling design. Right now, we go to 3 methods available to the researchers when they want to draw a sample randomly for their study. The first one and the most familiar one is the fishbowl draw. It's like a lottery or a lucky draw. So it only applicable. It's only practical if the population is small, like 30 students in the class, and you want to select 10 to start their presentation, next week, and another 10 gonna be randomly selected and give the presentation the following week. You could do that. You could apply the fishbowl draw or the lucky draw if the population is small. So what we need to do is to write down everyone's name on a piece of paper, scroll pieces of paper, put them in a box, shake very well, and randomly select 5 or 10 from the box or from a hat. So this process is very random. No one is going to influence who's gonna be selected. It's up to the luck of being or not being selected. A second method of taking a random sample is to use a computer program. There are so many computer programs out there that allow us to generate a random sample. Excel is a classic, is a good example of a software that allows the researcher to randomly generate a sample. And the third method of taking a random sample is to use a table of randomly generated numbers. Again, the numbers are randomly generated by a computer programs. This third method applies and is very practical, very powerful when we have a large population. For example, our population could be 1,000 or 2,000 or 5,000, and using the table of randomly generated numbers allows us to select the predetermined sample size that we want. In order to use a table of random generated numbers, we need two things. Number one, we need the sampling frame. As you remember from the previous lesson, sampling frame is nothing more than the complete updated list of the population. And we also need to have a table of randomly generated numbers. Luckily, the internet provides such table, or you can find such table in the appendix of research methodology textbooks. Some textbooks, some authors are generous enough to attach a table of random number for us to use free of charge. So to sum up, ladies and gentlemen, there are three methods for drawing a random sample, and we shall move to the next page, the next slide. As you can see here, this is a short demonstration of a table of random numbers. You can see here we have the first column, second column, third column, column 4, column 5, column 6, column 7, 8, 9, 10, 11, 12, 13 columns, and multiple rows, row 1, row 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 23, 24 rows. This is a classic example of table of random numbers. So in this lesson, we particularly highlight how to select a sample using a table of randomly generated numbers. So some concepts regarding how to use a table of randomly generated numbers. First of all, the first step, we need to identify the total numbers of elements in the population. So we need to have we need to know the exact number of participants of the whole population. For example, at high school A, we know that there is a total of 550 high school students. So 550 refer to the total number of elements in the population. And the next step is to assign a number to everyone, starting from 1 until the last participant. And after that, we need to randomly select a table of random number. If the table runs from the first page to page 4 or page 5 or page 6, so we need to randomly select one page as the starting point. And step number 4, if we randomly select page 4, the next step is to randomly select a column or a row as your starting point, and we proceed from there in a predetermined direction. I will explain further on how to do that in a moment. If you happen to select the same number twice, discard it and goes to the next number. This is logic. This is common sense, because we cannot select the same participant twice. For example, if number 35 was already selected, and then we see that this number happens again, we're gonna skip this number and go to the next number to select the next element. And another step is to keep going until you have to reach your determined sample size. If you decide to select 80 high school students for your quick survey, you keep going until you have reached student number 80. For a demonstration, let's do it together here. Let's have fun in applying what we have learned so far. So for the demonstration and for illustration, I have the sampling frame. So in total, there are 21 participants in this population, but as you are well aware that a population might be much bigger. It could be very, very big, like 5,000 or 2,000 people. But for quick application, imagine there are 21 people in this population. The first one is Dara, second Adam, Naren, Wati, Sari, Vana, Bunhei, Narong, Sangha, Sapal. The list, the Lin, Kamsreng, Sapip, Rabut, Bunlong, Pisai, Samnang, Pisit, Bunat, and Supir. As already stated, each of them is assigned a number from 1 to the last person in the sampling frame, from number 1 to number 21. This is the sampling frame with the assigned number, and this is the table of random numbers only on one page, but in real life, in real world, there are more than one page. There's more than one page. So if there's more than one page, we need to randomly select the page. That's the first step. And second step is to randomly select the rows or the columns. Let's try to randomly select the page. Let's say this page is randomly selected, and after that we need to randomly select a row or a column. Imagine I randomly select this row, and I happen to select the last 2 digits of this row of this column. The last 2 digits is 0, 1. So you look at the list. As you can see, there is a total of 21 participants in the population. Imagine we are going to select 6 of them. Okay, so 21 is 2 digits, 99 is 2 digits. If your population is 120, it is going to be 3 digits. Okay, so we have 2 digits. So we come back to the row, column we randomly selected, so 0, 1. So Dara is the first participant randomly selected. Scientific, so scientific, no interference, no human influence. We have nothing to do with the fact that Dara is randomly selected, because we randomly select the page, we randomly select the column and the row, and then we go down. We have to be strategic, to be scientific in the direction that we go. I recommend going down like this. The last 2 digits, you go down. Participant number 24 is selected next, but this number exceeds the number of participants, so we have no participant number 24. Therefore, so far only one is selected. Dara is selected, and then we go to 04, the last 2 digits. So Wuti is selected. So Wuti becomes participant number 2, and we go to participant 31. We skip him because this number exceeds the number of population. 78 is also skipped. Number 12, Dalin is selected. So far we have selected 3 people. Number 43 we skip. 60 we skip. We also skip 36. We skip 39. We skip 79. We skip 86. We skip 34. We take participant number 6 here. So participant number 6 is selected also. He is also selected here. Okay, so we have number 6 Wana, and we go on. 96 skip. We skip 94. We skip 71. We skip 75. We skip 96. We skip 43. And this is now we come to the end of the column. So what's next? As expected, we have to be strategic. We have to be predetermined. We don't mess up. We need to move, in a forward direction. Therefore, we can go to the last 2 digits in this column. So 64 skip, 92 skip, 38 we skip 30, we skip 61. We gonna select 21. Superior is selected. So we keep going. 54. We skip 58. We skip 39. We skip 47. We skip 52. We skip 67. We skip 57. Skip 54. Skip 90. Skip 73. We skip number 14. We select number 14. So far, let's come back. Number 1 was selected. Number 4 selected. Number 12 selected. Number 6 selected. Number 21 selected. Number 14 selected. And we need to go on. We need to go on in order to select the last one, because our predetermined sample size is 6. We are going to interview the 6 participant. We go on. So here we have number 2. So number 2 is selected. And finally, ladies and gentlemen, it seems that we get we have reached the desired number that we want. That's how you make use of the table of random numbers in order to select the desired sample size that you want. So I hope you enjoy this. I hope you find this beneficial, and happy ending. Thank you very much.